Okay, we are graphing square root functions, and square root functions, which are the inverse of a parabola, means that it's like a parabola that fell over. So they actually look kind of like an eyebrow would. So if you can imagine, it starts in the middle and just kind of tails off to one side. So it's like one eyebrow that lost its friend. Anyway, so here it is. My first thing that I would want to find is this special point right here. And this is called the vertex. So I can find the vertex of a function like this by asking myself, hey, when does this x plus 4 inside equal 0? Since the lowest possible number I can ever get inside a square root sign is 0, when x plus 4 equals 0, that's where this thing is going to start. So, well, that's going to happen when x equals negative 4. So my first point that I want to plug in is x is negative 4. So if I plug in a negative 4, I get negative 4 plus 4, which is square root of 0, which is 0. So 1, 2, 3, 4. That's my vertex. So my next point that I want to find, I can plug anything I want in here, but some points with square roots are not going to turn out pretty. If I can turn this x plus 4 into a perfect square, then I am going to end up with a nice number. So for example, if I chose negative 3 and I plugged it in, I would get the square root of negative 3 plus 4, which is the square root of 1. And of course the square root of 1 is just 1. So if I can produce a nice number inside a perfect square, I'm going to get a nice answer. So negative 3, 1, it's right there. So what's my next perfect square? It's a 4. So how could I make x plus 4 equal 4? Well, if x was 0, that would work. So I could get the square root of 0 plus 4, which is just the square root of 4. And of course the square root of 4 is 2. 0, 2. So I can actually go through this. I can do it for 9 too. How could I make this equal 9? Well, if that was a 5, I could get 9. So if x is 5, I'd get the square root of 5 plus 4, which is the square root of 9. So that would get me a 3. So I could count over 1, 2, 3, 4, 5. 1, 2, 3. That's going to be this right here. So I get an eyebrow function that looks like that. And now, last chunk is to find the domain and the range. So my domain, remember my domain is my x values. So what x values am I allowed to use here? Well, this graph doesn't exist over here. It only exists on this side of the vertex. So that's negative 4. So I'm only allowed to use numbers that are bigger than or equal to negative 4. And my y values, my range, well, if I'm looking for my range, this value doesn't exist below 0, just above 0. So my y values have to be bigger than or equal to 0. So that's my first graph. Let's talk about the second one. Second one's a little more complicated, but I'm going to start the same way. I'm going to find my vertex. So to find my vertex, I need that 3x plus 4 to equal nothing, which means I move the 4 over. That 3x has to equal a negative 4. So for that to happen, x has to be negative 4 thirds. So if I plug in a negative 4 thirds here, I do get 0. So negative 4 thirds is a little bit below or a little bit in front of 1. So the next number I want to pick, remember my perfect squares, it would be great if this was worth 1. So how could I make this produce a 1? Well, I could write an equation equals 1 and solve it. Or I could think about it's going to be really close to this point, and if I choose a negative 1, I would get 3 times negative 1 plus 4. So this function would be the square root of negative 3 plus 4, which is 1. And that's how I can get my 1. So it involves a little bit of thinking. What can I plug in? So I'm going to get negative 1. 1 would go right there. And now what else could I do? Well, it'd be great for me to get the second perfect square of 4. That one should be easy, because if I can get rid of this 3, I can make that happen. So what numbers make the 3 disappear? 0. So the square root of 3 zeros plus 4, which is going to be the square root of 4. So that's going to be worth 2. So 0, 2 is my next point. So see how steep this is? It's steep because we have a leading coefficient of 3. So that's going to be real steep. It's going to go up like that. There's my eyebrow function. Now I just need my domain and my range. So once again, my domain is my x values. Where does this start happening? Well, it starts happening on the vertex. And the vertex here is negative 4/3. So I need all the numbers to be bigger than negative 4/3. And the final thing, my range, once again, doesn't happen below 0, only above 0. All these y values are above 0. Y is greater than or equal to 0.